And welcome to All Hands on DAQ. It's a joke about shipping, because it sounds a bit like All Hands on Deck, and that's what that is. So, why is it a shipping joke? So here we see the lovely Docker whale. The Docker whale is a ship of sorts, and it holds containers. And DAQ uses Docker quite a lot, so it's just a nice way to, as an intro to the series. So the idea of this whole thing is it's meant to be a crash course for people who want to kind of get their hands on DAQ, get it running, and then as the series progresses, we will see briefly how to interpret the code of DAQ itself and how to extend it as time goes on. Because as with most things, the best way to learn something is to intertwine a bit of theory and a bit of practice. So this is mainly going to be the practical side of that, with kind of a small dose of theory as time goes on. So, first things first, who am I? So I am this person in Bruges on GitHub. I'm Jason. I'm a software engineer based in London, and I've been working with DAQ now for about a year and 2 months, let's say. And it's been great, and it's been a journey, and hopefully I can bring you on the journey that I've been on, and you can learn to love DAQ as much as I do. Mush your stuff over. So what is DAQ? Among other things, so the bottom there, it's open source software, which means that the code and the documentation for such a thing is readily available. Which, among other things, means that if you find a problem with DAQ, you can just post an issue there, or you can go on the mailing list, and you can hack around with it yourself if you are so inclined. We'll go through some links for how to do that later on. So DAQ is an acronym as well. It stands for Device Automated Qualification. What devices are we talking about? We're talking about IP connected devices. For the sake of argument, let's just think about things that have an Ethernet port. So it can be a laptop, it can be a Raspberry Pi, it can be a HVAC controller, it can be a lighting controller, but it's anything that's got one of those ports. So we have devices that we want to test. We want to test them in an automated way. So we have many devices. We just want to plug these devices into something and have DAQ test it. It doesn't really matter how many devices we have. We want those tests to run maybe over and over again, maybe just once. And at the end of it, we want to get some level of qualification. So what does qualification mean? In the context of cybersecurity, we want to make sure that the device that we're testing is basically configured correctly, so it'll be secure enough in our system. And the systems we're going to be talking about mostly in this series are going to be building systems. So in the realm of IP connected devices, we've got HVAC controllers, lighting controllers, or anything within the realm of BMS. So devices like what? What does HVAC and BMS mean? So I'm talking about devices like these. It's kind of what DAQ is designed to test. So HVAC, back when I was first starting out in this world, I thought it stood for high voltage air conditioning, but it doesn't. It stands for heating, ventilation, and air conditioning. So I was almost right. BMS, you think of that as a building management system. So if you think about something on the scale of a 10-story building. Each floor you have a system of lights which you want to say turn off at a certain time of day. You want these lights to be connected to kind of proximity sensors like PIRs or something. So you want a system to connect together a sensor and some lights, maybe a temperature sensor and a heating control system. And these boxes down here do exactly that. So these boxes can communicate via sometimes IP, growing a growing number of devices communicate over IP these days, and they communicate with each other through other protocols like BACnet and Modbus and LON and all this other stuff. But for the sake of for this, just think of these boxes as sort of generic I/O controllers. So you can plug in a sensor to one of these inputs, and you can plug in a actuator, motor or something into another output, and you can connect the two together. So each of these different manufacturers, so EasyIO or DiskTech or Honeywell or whatever, they might use the Tridium Niagara framework to configure what happens between these inputs and outputs. Yeah, and that's kind of what they do. So again, why does DAQ even exists? So again, if we think about a building on the scale of 10 stories, let's say for the sake of argument we have 1,000 devices in this building. So we've got 1,000 of these little controllers here. That may not be realistic, but it works for the sake of this example. So before you install everything, so let's say we've got a new building, right? So before you install everything, you commission a device. So you set up this device. You will maybe set up the the internet security kind of stuff on this. So you might close some TCP ports, you might open some TCP ports and UDP ports. You might set up some sort of SSL certificates to transmit your data over the wire more securely. You might do all that, and you've got to do that 1,000 times. And there's kind of currently no way of getting around that, although the industry is changing faster than you'd think. But basically, the first step is commissioning a device. But then, to make sure it's qualified from a security perspective to be installed in that building, you have a human being test it for basic operational and security requirements. So a lot of these devices have 2 Ethernet ports and one. So down here, there's Tridium one here, 2 Ethernet ports. For your installation, for your building, you might only want one of these ports to be active, because if this is installed and it's got an Ethernet cable in it, you don't want some bad actor, some nefarious dealer coming in and plugging in the laptop to the other Ethernet port and potentially stealing all of your data or controlling your building. If anyone's seen Mr. Robot, then I don't know, it's entirely possible. Even though it's fictional, it's kind of close to home. So you might want to test that. You might want to test a variety of other things as well to make sure that this device is secure enough. So you've got N devices, and then you have one human to test, let's say, 1,000 devices. Yeah, well, you just kind of do that. So the time it takes for one person to test one device manually could be something as small as 10 minutes, let's say. But if you times that by 1,000 devices, then you've got 1,000 times 10 minutes. It's 10,000 minutes, which is many hours, many days. And you've got to pay that person. Blah, blah, blah. And after the installation, you just kind of hope that everything keeps working on the production in inverted commas network. The production meaning, some day to day, there are people in your new building and they want a comfortable environment to work in or do whatever they want to do in. And yeah, so after the installation, you just kind of carry on hoping that it works. And then to make sure that everything is still secure, you might employ some penetration testing, let's say. So you might get an external third-party company to come in and attack your network and attack your devices. But when do you do that? Do you do it every 3 months? Do you do it every 4 months? I don't know. What time of day do you do it even? I mean, do you do it always in the nighttime when no one's there? Is that realistic? Should we be testing things throughout the day when people are in the office, when the network is most operationally kind of ready and stuff like that? And what does penetration testing even mean? So let's say it's June and you've decided to do some summer security testing for your company. You get company A that have one method of testing things, and then November rolls around and you want to do some security testing, penetration testing again, and you get company B to do it because company A went out of business. I don't know. And company B may have a different method of testing things. So okay, so that's fine. We can do that and everything goes well. But if something goes wrong, we commission a new device and then we get another human to commission the device, which is kind of the sort of lowest common denominator here. And we have the human test it again. We test it for the basic requirements that we need. And then outside of the realms of penetration testing and commission, so during the business as usual, the BAU, the BAU operation, what do we do there? I don't know. So let's say these devices are sending something to the cloud, so they might send off telemetry data for sensors. Telemetry data for temperature sensors, let's say. There might be telemetry data from the position of each lift in your building. So lift 1 is on floor 2 right now, but you want to track that. And we want to make sure, hopefully, that these devices are still sending data. So you want to make sure that maybe the temperature sensor in room 2 of floor 4 is sending data every 5 minutes, because that's what you're expecting to see on your monitoring systems, and you just kind of hope that happens. There's nothing there at the moment anyway to test that that data is coming as frequently as you expect it. There's nothing to test that during the sort of firmware updates of these devices that everything's still working as expected. So that's kind of the biggest grey area that DAQ attempts to make white, basically. Yeah. So what DAQ does and how it compares to the current approach for many devices in the building. Before installation, you test the device using DAQ. So DAQ runs on a laptop or a server or something. It runs on a computer, machine. You plug the device into DAQ and it tests it automatically, which removes the manual process of a manual testing operator ticking things on a spreadsheet, and you get a report, and it gives you a pass or a fail. If the device passes, then that's okay. So it's probably secure enough, it's configured correctly, and you can put that to the side and put it in the big box of devices that you're going to install in your building. If it fails, then the report tells you why it fails, and maybe you've just configured something wrongly during the commissioning step, and then you can just change that, and then you just kind of carry on until the device passes, I would say. And this is based on a given site configuration. So there might be, so say you're a company that is building lots of buildings. Each different site has a different level of security, let's say. So one is, I don't know, maybe it could be something to do with a government site or something. So you want, extra high security. The other one is, I don't know, maybe a storeroom or something. So it doesn't need the same level of security as you would need in other sites. So DAQ has the ability to differentiate configurations between sites, essentially. After the installation, DAQ keeps running. So DAQ runs on your site as well. And when you plug in the device into the site, DAQ knows that it's there, and it tests it again. If the device still passes after the commissioning step, then you can let it onto the right network segment, VLAN, let's call that for the sake of argument now. And if it fails, do not let that device onto the network at all, because it's not secure enough and it might be compromised at any time, that kind of thing. And then, depending on how you trigger DAQ, depending on how you run it, you can continue testing the device indefinitely. So that if during a firmware upgrade from a manufacturer, something changes, and it changes to the extent that it's not fulfilling the requirements of your site configuration anymore, then it'll just take it off the network, and that's how everyone stays happy and safe. Yeah. So during the BAU operation, we current testing the device, passes good, if it fails, and then it's the same thing as before the installation. If the device fails, then you get a report after every single test, so you know why, and you can, potentially just remove that device from the network, and then sort of put it back in, or not, depending on what you want to do, depending on your own procedures. So, how does DAQ do this? And it's at this point I want to first draw attention to the wiki. So, as I said before, open source project. So here's the code, and here is the wiki. So it's right there. Welcome to the DAQ documentation wiki. And this kind of goes over some initial tutorials, which this video series will kind of loosely follow. And it tells you why DAQ exists and how it kind of does it. But in very, very simple terms, it's a sort of a very quick crash course slide. So DAQ runs on top of a software-defined network running OpenFlow 1.3. So a software-defined network is the idea that each switch can be configured remotely, and it can be configured sort of on the fly based on what's happening, in very, very, very simple terms. So there's a software-defined network which is running the protocol OpenFlow 1.3. Each switch on your network topology is also running OpenFlow 1.3. And then beyond that, DAQ has written in a good deal of Python. It uses a good deal of Docker files and a very, very, very good deal of JSON configuration files. So I'm not going to cover what these are. So hopefully anyone who's reading this, watching this, both, will have a good idea of what Python is, what Docker is, and what JSON configuration files are used for. It's all very high level stuff, and if you don't know what any of those are, it doesn't really matter, because I'll go through how to start DAQ, run DAQ, hack around with DAQ, and then hopefully you can pick up those things as we go. So, who is DAQ for? Aside from you, it's kind of designed for system administrators. So DAQ doesn't have any fancy GUI yet, no fancy GUI. It's not anything like Cisco Meraki or anything like that. There's no kind of it's not slick in inverted commas just yet, because it's still so in DAQ is in flux and DAQ is young, as I say at the bottom there. It's for those comfortable pulling software from GitHub. So we'll be installing DAQ by Git cloning and stuff like that. We won't be building from source, let's say. We kind of will, but Docker will do that for us. And it's for those interested in ensuring the sustained security of IoT devices in a building. And also it could be for just the curious. I don't know. So DAQ, the reason I like DAQ so much is because it kind of encapsulates a lot of quite esoteric concepts in one quite easy to digest kind of package, really. So good. And yeah, so at the moment, DAQ is in flux. So version 1.0.0 was released last year, and things are still changing every day. So we use Semver, so there aren't that many breaking changes just yet. But if we just look at the kind of commit history on Faucet's SDN/DAQ, we can see there's 410 commits, and it's it's like 5 days ago, 6 days ago, at the time of recording, which is on the 27th of January at about 2:18 p.m. Okay, so where's the code? I've already gone over that a couple of times. So this is the sort of the public-facing repository. There are others that use for development, other developers, but I won't go into those because this should be so Faucet SDN/DAQ is the most stable version that exists. And for this tutorial, the version of DAQ I'll be running will be exactly this commit right here. If you are working on the sort of bleeding edge of DAQ, then you'll be working on a different commit. But the reason I'm just focusing on one commit here is just so I can ensure that this tutorial works and works the same for every single person. Yeah. So, are there any docs? Yes, there are. So there is the wiki right here, which we've already touched upon before. A load of tutorials, loads of stuff about mod files, and using DAQ with a real live switch, which we'll get to in the latter half of this series. And aside from that, we have some other docs as well. So these are kind of more actively, well, if you can say this, these documentation files here are more actively developed than the wiki. So for the latest documentation, look here rather than the wiki, because the wiki could trail behind significantly. Yeah, okay. And can you get these slides anywhere? So there should be 11 videos in this series, and all the slides are here. And yeah, so this is just on my Google Drive, and I've set up link sharing, so anyone can view the slides, but not edit them. Sorry, guys. And yeah, where is the community? So any good open source project with any amount of reach needs a community, in my view. So if you go to that link right there, then you will find the groups.google.com kind of message board style thing. I have already requested access to this, so when you go on this link, you'll see that things like request access, and there's no, secret handshake to get in. It's just, so there aren't people who don't necessarily care about DAQ posting random things, and of course to avoid spam, which is always useful. Yeah, so this is where the wider community worldwide. So we've got some guys in Singapore, we've got some guys in America, we've got some guys in UK, of course, who are asking questions and suggesting fixes and suggesting features. So this is where that happens. Okay, and I think that is it for this number one. Yeah, so see you in the next one.